Welcome to RCA Robotics demo. I'm Sina Sara, Academic Leader in Robotics at Royal College of Art. I'm here today with two other colleagues, Shahruz Shaheen and Rasul Sadeqian, both researchers within the RCA Robotics Lab. We make robots that can enhance human safety, access, and performance for use in a range of industrial and medical operations. Examples of our work: wind turbine blade robots, blade repair robots that can be transferred to wind turbine blades using flying drones, and then it can walk there, detect cracks on the blade, and repair them without the need for human presence in that extreme work environment. We also study how animals attach themselves to the environment using organs such as suckers, claws, and spines, and then make multimodal attachment mechanisms that can autonomously decide and deploy a right mode of attachment depending on the properties of the contact surface. In this example, we attach to a porous volcanic rock using spines. Today, we have an exciting demo for you. We will show how a mobile manipulator can detect and retrieve hot objects from the oven and hand it over to a human worker to carry out a follow-up task. We look forward to receiving your comments and questions in the chat afterwards. I hope you enjoyed the demo. We are happy to take questions now. So, Shahruz, can you please check if there are questions? Okay, there's a question how the robot, in fact, can detect the stamp. So we use a contour detection algorithm based on anomaly detection. So we have we know actually how the internal structure of the oven is, and we compare it with the current structure, current changes in the oven's internal structure. So I mean the difference between two with the object which is there, and this is the way we detect the stamp. So we have two real sense depth cameras actually that is used for this. So one more question, what type of cameras do you use in this robot? And we have 3 cameras. So one on the arm and 2 on the base, one in the front, one on the back. And the 3 of them are RealSense 45i depth cameras. So if I want to explain it further, the depth camera on the mobile base will help to estimate the distance with the oven, and once we are close enough to the oven, the oven's door can be automatically opened, and then the arm extends to grip onto the stump inside. So if there are no more questions for now, we can go for a break and return at 4:30. Welcome to RCA Robotics demo. I'm Sina Sara, academic leader in robotics at Royal College of Art. I'm here today with two other colleagues, Shahruz Shahin and Rasul Sadeqian, both researchers within the RCA Robotics Lab. We make robots that can enhance human safety, access, and performance for use in a range of industrial and medical operations. Examples of our work include this wind turbine blade robots, blade repair robots that can be transferred to wind turbine blades using flying drones, and then it can walk there, detect cracks on the blade, and repair them without the need for human presence in that extreme work environment. We also study how animals attach themselves to the environment using organs such as suckers, claws, and spines, and then make multimodal attachment mechanisms that can autonomously decide and deploy a right mode of attachment depending on the properties of the contact surface. In these examples, we attach to a porous volcanic rock using spines. Today, we have an exciting demo for you. We will show how a mobile manipulator can detect and retrieve hot objects from the oven and hand it over to a human worker to carry out a follow-up task. We look forward to receiving your comments and questions in the chat afterwards. I hope you liked the demo. Now we would be very happy to take questions. Shahruz, could you please check if there are questions? There's a question that is that an autonomous robot? Yes, it is partly autonomous. So for example, we are able to autonomously detect the location of the stump inside the oven and retrieve that. Or we are able to autonomously detect if there is any pulling force applied to the gripper, and at that time we are able to release the stump, for example, or other objects. And so we are able to autonomously detect the distance with between the robot and the oven, and at that time the oven's door can be autonomously opened. So I would say yes, it is the segments of the system are each autonomous. So there are other questions. Any effect of articulated manipulator mounted on the mobile base? How does the inverse kinematics work together? So I need to mention something that this type of the arm basically cannot work with the base. They cannot move at the same time. So this type of arm basically is not made for this. So while the base is moving, the arm is locked, and it can only work when the base is in stationary position. Other questions? So what type of camera do you use in the robot? So we have 3 cameras here. So one is so that 3 of them actually are real sense depth cameras. I think they are 435i, and 2 are on the base, one in the front, one in the back, to basically estimate the distance with other objects in the room, and one on the arm to that helps actually finding the stump in the oven, for example. Would it be able to take bigger objects? Yeah, we can take as big as the gripper can afford, actually, of course. How do you measure the distance to the object? So we basically use the cameras that I mentioned, the depth sensors, actually, to measure the distance with the object. So the distance with the stamp is, of course, from the camera which is installed on the gripper itself. So the way how it can detect the stamp. So the way we detect the stamp is by using the contour detection algorithms that helps us to find anomaly in the image. So we have we know the internal structure of the oven prior to adding any object there, and also we have the current structure of the oven with an object such as a stamp there. So by comparing the two, we can locate any additional object inside the oven. Once the robot approaches the oven, so the door can be open, it can detect the object there. It can extend and grip onto this, and then move back towards the person sitting somewhere else inside the room. In that case, it's me sitting there, of course, and then there is a threshold actually on the pulling force applies to the gripper there. So once it passes the threshold, then it can release the stamp to me there, and then I will be ready to use the object that is handed over. So any other questions? So if there are no more questions, so we can have a break and come back at 5. Thank you. Welcome to RCA Robotics demo. I'm Sina Sara, academic leader in robotics at Royal College of Art. I'm here today with two other colleagues, Shahruz Shahin and Rasul Sadeqian, both researchers within the RCA Robotics Lab. We make robots that can enhance human safety, access, and performance for use in a range of industrial and medical operations. Examples of our work include this wind turbine blade robots, blade repair robots that can be transferred to wind turbine blades using flying drones, and then it can walk there, detect cracks on the blade, and repair them without the need for human presence in that extreme work environment. We also study how animals attach themselves to the environment using organs such as suckers, claws, and spines, and then make multimodal attachment mechanisms that can autonomously decide and deploy a right mode of attachment depending on the properties of the contact surface. In these examples, we attach to a porous volcanic rock using spines. Today, we have an exciting demo for you. We will show how a mobile manipulator can detect and retrieve hot objects from the oven and hand it over to a human worker to carry out a follow-up task. We look forward to receiving your comments and questions in the chat afterwards. We hope the demo was interesting to you. Now we would be happy to take questions if there are some. So there's a question that what is the next step in this research, what the robot can do next? So this robot, actually, in fact, is comprised of two parts. So one is an industrial front-chemical arm, and which is integrated into a mobile base that we made from and designed and made from scratch at RCA Robotics Lab. The The base has a number of unique features, such as that are related to the design. Basically, as you can see, the wheels are inside, that as opposed to be extruded outside. So this makes the control simpler, and it makes the robot safer for interacting with the environment. And also it has the hardware and software to autonomously react to the events in the environment. So the base is also made from very lightweight material, from aluminium, and so relative to other commercial counterparts, that this is much lighter, and it can take similar payload. So it can be used for applications that need high ability to maneuver in the environment, such as warehousing. So that can be a suitable application for this type of robot, or other applications indoor. So these mechanical wheels are mainly for applications indoor. So it can be used, the overall robot with integrated arm can be used for laboratory automation. So for example, to handle hazardous chemicals in the lab, and to represent human for that kind of tasks. So if there are more questions. So there's a question about the blade robot. So the blade robot is basically made to fix issues on the leading edge of the blade. There's an important problem with the leading edge, where that's called leading edge erosion, and this robot is able to fix the leading edge erosion problems actually by sanding, cleaning, and filling and forming of the leading edge, basically what is called resurfacing of the leading edge, to recover the original shape and surface texture of the blade. So this robot in fact has a translation base at translation stage at the base. So it enables moving the arm in this area of half a meter. So within that half a meter, the crawler base actually doesn't need to move. So we have very large workspace, so we can reach locations on the blade that are 50 centimeters away without the need to move the robot at all. If we need to reach other locations, then the crawler has 4 feet actually that can attach to the blade and move the base to different locations on the blade. So the wind turbines blades are getting progressively larger and larger, because by this actually you can increase the output of the amount of energy we can harvest in this way, and therefore it's important to find ways to repair them and maintain them frequently. So if there are other questions. How do you measure the distance to the object? So we have 3 sensors or 3 cameras integrated into the robot, 2 into the base, 1 at the front, 1 at the back, and 1 on the gripper, on the tip of the robot arm. So the 3 of them are RealSense 435 by depth cameras, and of course the ones actually which are on the base are used to locate or measure the distance with, for example, the oven as it approaches. As the robot approaches the oven, the oven's door should be open. So and then the one on the arm is used to estimate the distance and locate the stamp which is inside the oven. Thank you. Would it be able to take bigger objects like a cake, for example? It can, in fact, yeah, it can take cake if the cake is on a base, which is rigid, then we can take the cake from the base. Is it feasible to use the robot for fire-rated applications? So the robot is not fireproof, but yes, I mean there are opportunities to make it fireproof, but perhaps not with this arm. So we need to replace it with an arm that is able to work over a larger temperature range. How it can detect the stamp? So we have we have an contour detection algorithm that helps us to detect anomaly inside the oven. We have and we know the internal structure of the oven, and also and we compare this with the current structure that is seen in the image, and the difference between the two can help us to locate any additional objects inside the oven, and this is the way to detect the stamp. As the robot arm, and in fact as the mobile manipulator approaches the oven and the door is opened autonomously, so the RealSense camera on the gripper can help us to detect the location, and the arm can extend to grab it. Thank you. What type of cameras do you use in the robots? Yeah, as I mentioned, like there are 3 cameras. They are all the same type of cameras. They are RealSense 435, and they can provide they have an IMU inside and also a depth sensor. So if there are no more questions, Shahruz can check, please. So thank you for your question. If there are no more, then we take a break and we come back at 5:30. Welcome to RCA Robotics demo. I'm Sina Sara, academic leader in robotics at Royal College of Art. I'm here today with two other colleagues, Shahruz Shahin and Rasul Sadeqian, both researchers within the RCA Robotics lab. We make robots that can enhance human safety, access, and performance for use in a range of industrial and medical operations. Examples of our work include this wind turbine blade robot, blade repair robots that can be transferred to wind turbine blades using flying drones, and then it can walk there, detect cracks on the blade, and repair them without the need for human presence in that extreme work environment. We also study how animals attach themselves to the environment using organs such as suckers, claws, and spines, and then make multimodal attachment mechanisms that can autonomously decide and deploy a right mode of attachment depending on the properties of the contact surface. In this example, we attach to a porous volcanic rock using spines. Today we have an exciting demo for you. We will show how a mobile manipulator can detect and retrieve hot objects from the oven and hand it over to a human worker to carry out a follow-up task. We look forward to receiving your comments and questions in the chat afterwards. We hope you enjoyed the demo. We would be very happy to take a few questions. If Shahruz can check questions, please. So there's a question that how we can detect the stamp. So we use a contour detection algorithm that can help us to detect any anomaly there. So we have and we know the internal structure of the oven, and we compare this with any current structure of the oven when there is any object in there. So the difference between the two can tell us the location of the object and if there are additional objects there. So there are there are three cameras actually on the robot. One on the manipulator, which is a depth camera. The depth camera can give you the coordinate of the object and also the depths there. More questions? Is it an autonomous robot? And so the tasks that are performed here are semi-autonomous. So, for example, the detection of the stamp there is done autonomously using that a contour detection algorithm. So, as the robot approaches the oven after a specific threshold, the oven's door can be opened, and then the arm extends towards the object, towards the internal space of the oven, and detect the object there. Then it can grip onto and move the object in the environment. Also, the other autonomous part, for example, is the delivery of the object or handover from the robot to human. So as a pulling force is applied to the stump that is basically is held by the gripper, when the amount of force actually passes a certain threshold, then the gripper opens and leave the stump or release the stump to the hand of the human worker. So these are processes, some of the processes that are autonomous. Also, the mobile base is integrated with another two depth sensor on the back and front. So these can provide information on the surrounding objects and be useful for the autonomy of the base. How do you measure the distance to the object? The distance to the object are also used by measured by real sense depth sensors that are integrated to the base of the robot. So we use 435i real sense sensors. So other question: what is the next step this research, and what the robot can do? So this robot is basically comprised of two main parts. One, a commercial robot arm, which is a front chemical arm. It is integrated into a mobile base that is developed from scratch and designed by RC Robotics Lab. So the base has a number of unique features actually in the design. So we designed under the mechanical design is somehow simplifying the control of the mobile base. We have, for example, wheels that are inside the robot structure as opposed to be extruded outside. So this can increase the safety and also simplify the control. And the base is made from lightweight material from aluminium, and comparing with commercial examples, commercial counterparts, it can take a similar payload of, for example, in this case, 150 kilogram, but it is much more lightweight comparing to them. So, and it is integrated with hardware and software to enable autonomy inside indoor environment. This type of robots can best be used in warehouse environment or in indoor environments where you need high ability to maneuver within the confined space, and it is basically realized by using mechano wheels. So with this type of robot, you can have sideways movements as opposed to only forward and backward and steering. So other application of this robot, for example, can be in laboratory automation. So it can be used to handle dangerous chemicals, for example, instead of human workers, and or objects that are hot, for example, within the laboratory, and other hazardous environments. So, other questions? Also, you said something about the blade robot. So the blade robot is made for a specific and significant issue which exists in offshore wind farms, so which is called leading edge erosion. The leading edge erosion problem, which is basically from the name, it happens at the leading edge of the blade. Reduces the performance of the wind turbine significantly, and therefore it is essential to frequently repair the blade and solve this issue. So the robot we made is able to attach to the side of the blade in that location, and to sand, to clean, and to resurface the blade using the filler material and recover the original shape of the blade. So using using two parts filler material, applying that. So we have like the unique features in that. Basically, as you move alongside the blade, the curvature of the blade changes, so which is an important issue there. So we made this specific spatula device on this that can change the curvature depending on and adapt to the curvature of the blade. We have an autonomous mixing and releasing mechanism for filler material that can tune the viscosity of the material to optimize it for deposition before it's released on the blade. And we have the ability to move the base without moving the base of the arm, without moving the robot itself within 50 centimeters. So to reach the cracks or erosion actually within half a meter, we can have a secure platform, a very stable platform without the need to move the crawler base. And this basically reduces the likelihood of the falling from the blade. And yeah, I think these are important things with the blade robot we have. So what is the application of the anchoring system? So the anchoring system is made for robots' feet. So basically, especially in climbing robots. So animals such as octopus, such as geckos, such as birds use different approaches to attach to their environment, and this more or less depends on the environment they are living in. For example, octopus arms are covered with 200 to 300 suckers, sensory suckers that can attach to the environment with varying degrees of force. So these are helping octopus to attach, for example, to rocks under sea to stand against storm surge and waves, and for example, in gecko to move on vertical surfaces, and to birds to perch on escalated structures, to branch of trees, and so on. But there is a need for development of anchoring mechanisms that are more universal, so they can reconfigure to adapt to the application or the type of environment they are interacting with. So, and this is the scope of our work. So we make autonomous multimodal mechanisms for attachment to the environment and integrate it into the robot's feet. And then when they are moving from one environment to the other, they can robustly operate. So they don't need to change the attachment mechanisms. So they can just adapt to the environment they are facing with. Can the robot cooperate with other similar robots? So I suppose actually you speak about the the mechano wheel robot. Yes, I mean they can. We have a communication system and basically information management system that can allow sharing information between the robot, and depending on what aspects of cooperation you are looking at, it's possible actually to cooperate with basically. We have done some of this in the past, with, for example, between a mobile manipulator and a stationary manipulator, so we can demonstrate the handover between the two, or some cooperative tasks. Thank you. So, if there are no more questions, can you please check channels? So it seems there are no more questions at the moment. If there is any questions, I would be very happy to receive it by email. So rcarobotics@rca.ac.uk, and we wish you all a nice rest of the day. Thank you.